Now, members, welcome to this lecture. In this lecture, we're going to discuss the contents or components of common fuels, and we are zeroing our discussion to diesel, petrol, and gasoline. Right away, let's begin with diesel. Diesel is a type of fuel derived from crude oil and is used in diesel engines. It is composed of mainly hydrocarbons along with various additives to improve the performance and meet regulatory standards. So now, one of the things that we add in this diesel include alkanes, and these are paraffins. So these are linear and branched alkanes, which provide high energy content and good combustion characteristics. The naphthalines, these are cycloalkanes, cyclic hydrocarbons that enhance fuel stability. Those are the naphthenes. Now, what about the other additives? Include the aromatics, and these are the ring hydrocarbons that contribute to density and lubricity of the fuel. The percentage of aromatics is usually controlled due to environmental concerns because aromatics are not good to the environment. For example, the case of benzene, it's not good to inherit or for humans to inherit because it has some carcinogenic compounds that will result into cancer. Therefore, the percentage of these aromatics needs to be controlled because of the above concerns. The other things that we need to add to improve the efficiency of diesel. Of course, in the manufacture of diesel, we have certain improvers, and these enhance combustion efficiency and reduce ignition delay. Detergents keep fuel injectors clean and improve engine performance. You have corrosion inhibitors. These protect the engine and the fuel system components from corrosion that would later on eat away the metallic components of the engine. Then the lubricity additives, they improve the lubricating properties of diesel, and particularly important for modern high pressure fuel injection systems. You also need to put antioxidants to prevent the formation of gum and varnish. Now, the antifoaming agents also are there to reduce the formation of foam during refueling. Now, let's talk about gasoline or petrol. So petrol, also known as gasoline, is a complex mixture of hydrocarbons derived from crude oil and used in spark ignition engines. It contains a wide range of hydrocarbons, types, and additives. The hydrocarbons that are in petrol include the paraffins, which provide a significant proportion of energy content and ensure good combustion characteristics. We have the isoparaffins. These are the branched alkanes. These improve octane rating and the combustion stability of the fuel. Aromatics also enhance the octane rating but are regulated due to their environmental impact, as we had earlier on said, for the case of diesel fuel. We also have olefins. These are alkenes present in small amounts. They contribute to octane rating but can cause instability. So their addition also needs to be controlled. Now, these are the additives. These are not the hydrocarbons. They are just additives that we put to enhance the combustion efficiency and the performance of this gasoline fuel. One is the octane boosters. These increase the octane rating to prevent knocking of the engine, and we always have ethanol and MTBE. Then other detergents that we also need to put keep the fuel system clean and prevent deposits. You need to also add corrosion inhibitors to prevent rust and corrosion of the fuel system components. The anti-icing additives prevent the formation of ice in the fuel system. Now, you need to also put antioxidants to prevent the formation of gum and varnish, and dyes used to distinguish between different grades of gasoline. Yeah, you need to differentiate the different grades of gasoline, and that's why you'll see diesel is a bit whitish or colorless, but petrol or gasoline, you might find it in different colors. So these are brought in by the presence of dyes. Now, we want to summarize the components that are in here. We said in diesel, we have paraffins, the alkanes, naphthenes, the cycloalkanes, and the aromatics. These improve, of course, the performance. These are the basic components that are in diesel as hydrocarbons, but then the additives which now improve the performance, we have certain improvers, detergents, corrosion inhibitors, etc. etc. Then the petrol has the following hydrocarbons that include paraffins, isoparaffins, aromatics, and olefins. Then they also have corrosion inhibitors, dyes, antioxidants, and anti-icing additives. Now, we wanted to also discuss in this video the hydrocarbons. These are very important, of course. These hydrocarbons are very important, and we will find that these are the hydrocarbons in which one or more hydrogen carbon atoms have been replaced by halogen atoms. For example, fluorine, chlorine, bromine, or iodine. These are the group 7 elements that react with the hydrocarbons to form what we call alkyl halides, or what we call halohydrocarbons. So one of them is the monohalohydrocarbons, and these are the components or the hydrocarbons in which a single halogen atom substitutes the hydrogen atom. So an example can be the chloromethane, the bromoethane, the iodopropane. A general formula for these monohalohydrocarbons is Cn 2n plus 1 and X. X represents the halogen atom. Then we have alkynyl halides. These are the haloalkenes. Haloalkenes, you'll find this comes from a combination of the halogen atom and the alkenes. So an example is the chloroethene, bromopropene, etc. etc. The general formula for alkynyl halides. So these are the alkynes where you have the alkynes. These have triple bonds between carbon and hydrogen atoms. So when you replace one of the hydrogen atoms with a halogen or a halide atom, then you will have this formula CnH2n-3X. And an example include chloroethane bromopropane. The other ones are the polyhalohydrocarbons, where multiple halogen atoms are replaced hydrogen atoms. And therefore, for alkanes, the general formula would be CnH2nX2, whereby X represents the halogen atom. An example is the 1,2-dichloroethane, 1,2-dibromopropane, and so on and so forth. Then you also have an example for alkanes. So you have also the 1,2-dichloroethene, the 1,2-dibromobutene. So when you follow the IPAC rules, when you go deep into this, the hydrocarbon, or what we call the organic chemistry, you'll be able to understand this. But for the basics of this course in thermodynamics, we shall just pass on top and we shall not go into details. Then we have the general formula for trihalides. These are the ones in which three halogen atoms react with, of course, the halogen reacts with the alkane or the hydrocarbon, but then uh, it replaces, that halogen atom replaces around three uh, hydrogen atoms. So an example is 1,1,1 trichloroethane, triple one tribromopropane. There's also tetrahalides where we have four halogen atoms replacing four hydrogen atoms on hydrocarbons. So one of them is the carbon tetrachloride that we know, the 1,1,2,2 tetrabromoethane, and so on and so forth. So you have also the aromatic halohydrocarbons, and these are the ring halohydrocarbons. So one of them is chlorobenzene, 1,2-dibromobenzene. So for example, where the halogen atom reacts with benzene, so you result into such compounds like the 1,3,5 trichlorobenzene. So here, this is the general formula for all the halohydrocarbons. So, ladies and gentlemen, we have specifically talked about, in this video, we have talked about um, the basic fuels like the diesel, petrol, or what we call gasoline, and we have gone ahead to also highlight about the halohydrocarbons. Thank you so much for listening. See you in the next lecture.